Here we go. Good morning, everyone. Welcome to the latest presentation in Inclusive Design 24-2017. My name is David Sloan. I work for the Paciello Group, and I'm introducing the next session, which is on Accessible SVG, presented by Chaals McCathie Nevile. By way of introduction, Charles has been, I guess, one of web accessibility's pioneer scientist experimenters since last century. Charles's personal biography tells us that he's old and tired, but sometimes does some useful stuff, including in accessibility. He's done a lot of useful stuff, including a lot of work in SVG accessibility, wrote perhaps the first independently produced SVG font, which also uncovered a piece of the spec where a crucial implementation detail wasn't mentioned. Charles speaks probably every language in the world, or if he isn't, he's probably learning it just now. But this morning, he's going to talk in English and tell us about accessible SVG. So I will hand over to Charles just now. Enjoy the talk.
Thank you, David. So actually, I speak Australian, which is close. If I could have the next slide and then the next slide, I'm going to cover the SVG past, a little bit about what happened, mostly talk about SVG right now, and then take a tiny peek into the future. And unfortunately, I shall probably cough some more. So SVG has been around for about 20 years. The SVG1 recommendation at W3C was finished in 2001. A lot of that was implemented in 1997, 98 sort of area. The SVG 1.1 specification came along. There was a second edition of that more recently. W3C spent a bunch of time working on SVG 1.1 and 1.2 tiny. These were profiles designed primarily for mobile phones because many mobile phones of that era, so long ago, were shipping with SVG on top of them. Next slide. There was other work that happened. A note called Accessibility Features of SVG, which was produced around 2000, and tried to explain how SVG might be good for accessibility. Unfortunately, at that time, a lot of the stuff was theoretical. Accessibility support in browsers was much weaker than it is now, and accessibility support of SVG was almost non-existent in practice. There was an effort to make an SVG 1.2, which was abandoned around 2005. Essentially, the people moved to something they wanted to call SVG 2. That was and still is in development. So there is no complete version. From about 2005, SVG started being implemented in what we would think of as mainstream browsers. By that point, you couldn't buy a modern mobile that didn't already implement SVG, so it was very widespread, but not in actual web browsers. Next slide, please. And the next slide. So bringing us to the present, SVG works in browsers. This is a roughly true statement. It more or less works in any modern browser you're likely to use. There is no clear specification of what works. And that's kind of tricky if you're trying to actually use it. Hopefully, SVG 2 will document that better, but we will come back to that question in the future. In the meantime, I'm just going to look through the things that do work and how they work and where they work, to give you a sense of the things that we can actually achieve. The next slide, please. So the first and most important thing, SVG, for those who think I'm talking alphabet soup so far, stands for Scalable Vector Graphics. It's a way of making graphics that scale nicely, rather than using lots and lots of different colored dots to fool you into thinking there's a picture. SVG describes lots of lines to fool you into thinking there's a picture. Either way, when you produce graphics, there are some simple things that you ought to do. So make it clear. If you could follow that link, please. This is an SVG graphic which was produced and offered up essentially as an example to play with. Thanks to IBM, who have offered a lot of examples, and we'll see a couple more and I'll point to some more things. For those who don't see the graphic, it's particularly interesting. There is a circle, sort of like a clock face, the names of the months around the circle, and lots of outlines of aeroplanes in 2 different colors. I have been looking at this graphic for about 3 years. I have absolutely no idea what it means, and I have absolutely no idea how to guess what it might mean. This is exactly what you don't want to do. Please avoid producing such graphics. When you use graphics, make them clear to people, because 99% perhaps, or 90-something% almost certainly of your users will look at it and wonder what's going on. If we close that and follow the next link, when you use graphics, the example here is a bar chart. It's a multiple dimensional bar chart, if you like. There are 2 different categories of bars, so they're grouped broadly, web, phone, and store, and they're grouped narrowly by particular categories within each of those. The problem is, looking at this graphic again, finding what any particular bar means is really complicated. And the main problem is there's just lots and lots of blobs of data. So if we close this and look at the next example, this has the same approach where there are, again, 5 different categories of item: phone, store. The data is, I believe, sales or similar kind of data. What they've done here, though, is use the very simple technique of providing space between each group. So now it's quite straightforward which block is which, and that makes it easier to interpret the data. What goes wrong with this particular graphic is, in a low contrast situation, all of the colors which are used to provide the information that's color coded essentially look the same. In a moderate contrast situation, they bleed into each other pretty badly. So although there is ordering used to try and make things clear, it's still quite hard to understand in a low contrast setup, or a situation where people suffer from color blindness. You're likely to start losing information rapidly. Both of those things are obvious problems for any kind of graphics. Nothing magic here at all. If we close this and then move to the next slide, please. One of the things that SVG does allow, and has allowed since the very beginning, is the use of CSS. You can put a simple style sheet into your graphic. I have here a genuine example using SVG elements to write the selectors, obviously. If you click on the link, then you'll see a very interesting image. This is a flowchart from the W3C process document describing how you make a W3C technical specification. Whatever. If you move around and hover over different parts of this graphic, then the CSS that we've used has a very basic means of highlighting which piece is relevant at the moment. In fact, you could tab around the diagram and you'll get the same kind of thing. So this is a simplistic way of doing it, but CSS gives you a lot of power to give people straightforward context information. If we can close that, please, and move to the next slide. There are a number of ways to actually use SVG. You write some SVG and you can have just a standalone SVG image that will render in any browser. You can use it through CSS as a background image, the way that people use, say, CSS sprites. You can use an image element in HTML. You can use an object element in HTML. From HTML5 onwards, you can include SVG directly as part of your source code. Next slide, please. Of those choices, 3 of them have some serious problems. If you use standalone SVG, Microsoft browsers in particular won't do any accessibility work. They just don't apply any of the accessibility stuff that they have when reading a pure SVG file. The next 2 is for a CSS background image. As with all CSS background images, there's no accessibility information available to the user. You can't interact with it. You can't put an alt attribute or any of the obvious things you can do in HTML. If you use the image element in HTML, and this is the first one that makes some kind of sense, then you can do the things that image usually allows. So you can have an alt attribute. You can add a long desc, and both of those enable you to provide, in some cases, perfectly sufficient information to ensure accessibility. You can't interact with the content. If your content is perfectly static, your company logo, that's no big deal. The TPG logo, for example, is just a logo that says the Pashello Group, and the alt attribute is perfectly adequate for that. For some kinds of data being presented, or for some kinds of picture, that's enough, so it's fine. But SVG is interactive, and so for a lot of the interesting uses, and even for a number of static pictures, you could do better. The next slide. This is mostly just code. If you use the HTML object element, which has only been around since 1998, i.e. about as long as SVG, then the image, and you can actually provide a fallback for browsers which don't support SVG. You need to do that right, obviously. The example here is how you do it terribly badly. If you get that fallback, then you may not have any idea what's going on. On the other hand, browsers do actually implement SVG, so people are unlikely to get the fallback in reality. Next slide, please. And the other alternative, again, a code sample, you can just put your SVG straight in line as part of your HTML code. It behaves as an inline rather than a block element for purposes of display. So as we will see, it's actually just part of the text, if you like. Next slide, please. So what happens when you use SVG? And my examples now assume that as with the slides themselves, the SVG is just inline somewhere in the HTML. Firefox and Explorer automatically recognize SVG as providing an image. So if you have some kind of image that's handy, assuming you want people to see that the image is there, it will be announced. Next slide, please. You can do something more than that. You can use Aria, and you can actually ensure that the thing is recognized by every browser by giving it a role of image. Next slide, please. One of the basic SVG accessibility features is that it has an element called title, and it has an element called desc, which is description. I'll come back to those. If you use the title overall for your SVG, that gives you the ability to provide something like an alt attribute. It's slightly more interesting because in principle it's an element. It's also used to give tooltips. The title attribute the title element can be used anywhere scattered around your SVG. So if you open the tooltips link and hover over the man moving slowly, then there are several different parts of the man. If you move up to, say, his head, and each of the parts of the man has its own title. This is a fairly simplistic drawing. The structure is arbitrary, but it's quite easy to clarify that with tooltips. They are built-in browser tooltips. This is one thing that people can get. If we close this and move to the next slide, unfortunately, this is very limited. The titles are not exposed to any screen reader. The information beyond being put in tooltips, which are controlled by the browser in terms of presentation, the information is not actually exposed. Using Aria, you can improve on that a little bit. You can actually provide your structure, and then you can use labeled by, so that the SVG image can be explored by a screen reader user in the same way that they would explore a web page, and they can find the names of pieces. Next slide, please. Similarly, there is a desc element for description, so that you can provide a more detailed description of the SVG as a whole, or indeed of any piece of SVG, again enabling that kind of nested structuring. The desc element, however, is not exposed by anything that I know of. So to make it even minimally useful, next slide, once again, you actually have to use Aria. So here we have another simple image. It's a rectangle. You need to put Aria described by with a pointer to the thing that is actually being described, the description. Otherwise, it won't be available. When you do put this in, it's presented by most browsers to most screen readers. It goes into the accessibility API and can be used. Next slide, please. One of the things that SVG provides is a text element. This has been there since the beginning. It has the relatively useful feature that it's presented by screen readers. It's real text, and you just position it, write the text, and it will get read out by screen readers. It is navigable automatically. Next slide, please. Originally in SVG, there was also a mechanism for writing fonts. These don't actually work in most modern browsers. That part has either been not implemented in many cases or removed in some cases. But you can use web fonts exactly the same way that you use web fonts for any other HTML. Those are a very common feature on the web. They're in about half of web pages, so I won't explain them further here. As I said, you can use CSS. There's another trick you can do, which is if you're drawing just plain lines which happen to look like text, and many people do this, unfortunately, then you can put a normal text element in the same place. In the example I've used, if you have a fill of none, in SVG each shape has a stroke width, and a fill. So if your stroke is in none or invisible, your fill is none, then you have invisible text there. And that behaves, this example will draw the text that you want, but there is real text underlying it. Although it's invisible, because there's a picture of text on top of it, people looking at it will see the right thing. You can actually trace over and highlight it. You can select it, copy it, do all the things you can do with normal text, including have it read to you. Next slide, please. In SVG, you can use links, except internal links. They're fairly straightforward. You make a link to something else in the same way as you do in HTML. I've used the old-fashioned xlink : href. You can just use a plain href as if it were a normal HTML link. It works the same. Next slide, please. So in the example you can see here, you could click on the first bit and be moved to the second bit of the SVG. It's very tedious and pointless in a slide. If you click on the explorable link, then I've used both links and a couple of other features so that you can tab through this diagram and actually find out what the links are. You can follow the links from one side to the other and back. Going back to my airline example, this is again a very unclear way of presenting some kinds of information. Making it explorable with links means that people can navigate around it, so long as they don't use Safari, because unfortunately that doesn't work at all. Equally unfortunately, it doesn't work brilliantly well in all browsers. So Focus sometimes follows the links and sometimes doesn't. However, it is a situation that's improving. If you close this picture and go to the next slide, there's a feature in SVG which allows you to create reusable objects. You define a little bit of graphics with an element called defs. Here we've defined a rectangle. We've put in a description because that's the logical thing to do. And we have a rectangle. If you go to the next slide, having defined those defs, we can use the same thing in different places. Technically what we're doing is producing a clone of the original defined thing. It should be a copy, and we can give it further characteristics. So here I've added different colors to different copies of that piece. I've given them a more specific title. If you go to the next slide, the reality of implementation here is kind of weak in browsers. Unfortunately, if you put anything interactive like a link inside the definition of your object, it will get into the tab order wherever that is in the source. So the user hits a definition that they can't see and is given an option they don't understand. Similarly, in the example I used, we put the description, the baseline description, straight into the definition so that it gets shared around, but that doesn't actually work. And although in standalone SVG, there are ways of referring to things that come from other documents, which enables a lot of reuse and mixing and would enable people to understand different bits. In HTML, the same origin policy essentially means you have to have your definitions in the same document. You can't reuse things as easily across different pieces of document. If we go to the next slide, again, we use Aria to work around some of this. So although you have to repeat your description in some place other than the definition, you use Aria described by. One of the nice features is this means you can stack up different pieces of definition. And in this example, I've used one description and pointed to it from two different places, so long as it's not part of the actual definition object, the def sub element. I can point to it from different parts of the same page. Next slide, please. SVG introduced, and all browsers have now implemented support for tabindex. This is great. This means that you can use SVG to define, for example, a button. Buttons are rectangular, as we know, so this example has a simple rect element. By putting tabindex 0, you get focus, and that works well. You can put it on anything. You could make it a circle. You could make it a piece of SVG or a part of the element. And the next slide, Aria, as we've seen, can be used to make various bits of SVG accessible, but all of Aria can be used. So in order to make our button more button-like, as well as giving it focus, we give it an Aria role, in this case, button. And then it gets announced as a button as well as being focused. And again, that actually works quite well. So if we go to the next slide, please. Aria and SVG works well as a new feature for the Aria that is supported in tools. So roles like button and table work brilliantly. Aria things like flow to don't really work at all. Some features of it work in some browser and screen reader combinations. The nice thing about having Aria is because SVG has very few native semantics. There are no interactive controls like HTML forms. There are no semantics for text. Using Aria allows you to actually make put that kind of information in and make your SVG more explorable, easier to understand, even for a static document, and gives you the ability to provide the same kind of semantic depth that you get in more or less real HTML. Beyond the first title element in your document, browsers use nothing out of SVG natively to provide information. So Aria does give you a very big boost in what you offer to the user. The next slide, please. So putting some of that together using Aria, if you click on this link, a highly meaningful link, we have here a line graph. This was actually taken direct from a commercially produced library that generates SVG graphs and information. These are charts that were generated originally from a table of data. You can navigate around this chart. You can look at it. It does lots of nice SVG things like enabling you to scale it. But in particular, if you look at this with a screen reader, the underlying information is encoded as an Aria table because it's a table of data points. It's a fairly straightforward table, and in testing this with users, we discovered that the table interpretation was actually quite easy to understand. Easier even than this graph, although this graph does a lot of the sensible things for graphics, like using different styles for the line, so that even with no color, you can follow the lines and more or less distinguish them. It should use CSS to make it clearer which line you're looking at if you hover from one to the other. The individual data points are labeled to provide more information when you hover over them. But as a screen reader user, it doesn't behave like that at all. It literally is encoded as a table, and that's done entirely using Aria. So if we close this picture, I have put a much simplified approach using normal Aria information for a table, a data table, and that's presented directly through various browsers. It's a nice way of understanding the data. The next slide, please. Various obvious features of SVG. In principle, because it's scalable, you can scale it, and it still looks nice. This particular example is a complex chemical interaction, which you can look up on Wikipedia, or not. If you open this up, then no, that's an article. If you open this up, you can zoom in on it and make it much bigger so that you can look at an individual piece. This is, for chemists, a fairly trivial example. There are much more complicated things that I had to look at in normal school chemistry. So being able to move into it, being able to explore piece by piece, being able to tab around all of these things are important features. Obviously, this is used for maps as well. When you look at a map, being able to close in on the area of the map you want is a pretty key feature, just visually. Close the image, please. The problem is SVG is not always scalable in practice. So I've put in a link because this is a well-described problem, and Amelia Bellamy-Royds has done a bang-up job of producing an article that tells you the nitty-gritty detail. Basically, when you create an SVG, you tell it how big it should be to fit in the page, and then you can start to mess around with it and change its size. In particular, if you're using it in Inline as part of content, then it will pick up the normal zoom and interaction of the page it's included in. And that's a very simple way of it being helpful. Next slide, please. Handling zoom can be interesting. If we think about the bar chart example from earlier, we have a bar chart and we have a legend to understand the data. If you start zooming into a graphic like that, the first thing that disappears is the legend that you were relying on to interpret the piece you're looking at now. There are various different ways that we can overcome that problem. If it's disappeared, you may or may not remember all of the different items. Here we have 5 colors. Obviously, if you haven't got the color presented clearly, that's a problem to start with. You can use titles on the individual items. You can also use some JavaScript for things on zoom and current scale. So you can actually determine whether the thing is zoomed and relay out the picture in ways that make sure that critical information is still close at hand. Vector effect non-scaling stroke is a way of creating a line that doesn't change its size when other things change. So for example, increasing the text size on a map, zoom in various features, but the stroke, the line itself, stays the same size. These are all tools that you could be using. And again, you also have CSS, so you can use media queries to look at the overall size, the minimum width, the screen width, and various other features. There is a logo for SVG that was produced by Doug Scheppers many, many years ago. It's all over the place, so I haven't included it here. And that uses media queries to find out how big it is, and actually quite radically changes the bits of SVG that are presented. It's very simple media queries using display and display none and display to change as you zoom in and out, as you make the logo smaller and bigger, and obviously simplifying it when it's very small means that the pieces are easier to see. The next slide, please. Next slide. So the last feature I'm going to talk about in SVG is animation. SVG Animation has been around since the beginning and is fairly widely implemented. It's handy primarily because it's extremely simple to use. It's declarative. You say what you want to happen and it happens. Animation is only a visual effect. It doesn't change what's in the underlying document. And that's a point I'll come back to. But in this example, we've taken an SVG line and we just changed how long the line is over time in 2 steps. So animation is automatically calculated. We just say where we want the thing to start, where we want the thing to end, and the browser does a lot of the hard work in filling in all the intermediate steps and calculating so that it moves smoothly. The CSS transformation stuff essentially copied this approach, making it very easy for authors to produce and even automatically produce animations and transformations. Because they're declarative, you can analyze the code and actually understand what's happening in a way that you couldn't do if you used individually created JavaScript, because you can't automatically analyze JavaScript by definition. Because this is regular, you can. If we look at the animation, click on the link, please, the SVG animation here. This is a terrible example. If you click on the heat button, you could tab to it and then click it, or you can click it directly. There is almost no JavaScript involved in this entire demonstration. What's going on? It's a fairly straightforward science experiment that lots of kids are told to do. You get an ice block, you measure its temperature as you heat it up, and if you heat it on a more or less constant heat, here's a Bunsen burner because that's what I had in chemistry. As the temperature rises, the ice block gets to 0, and then the temperature stops rising. And you melt all of the ice before the temperature, or nearly all of the ice before the temperature starts rising again. And for kids in high school class, this seems strange. They think that the temperature is going to keep on going up, and is used to explain scientific principles with which I won't bore you now. If we reload and start this again, and that's only the need to reload the images, hit tab and then hit enter, for example. We have a button. There's a status section here, and that status section changes as the temperature in the thermometer matches what's going on. So there are various ways of understanding visually what's going on. You can see in fairly clunkily drawn animation disappears, how the ice block melts. Changes are not actually calculated by anybody. It's the start point and the end point. So if we close the image, please. And this line example here, that is in fact the red line that's used to show the temperature against the backdrop of the thermometer. If we go to the next slide, there are lots of ways of starting an animation. You can use a click, you can use a time, you can use a date, in fact. You can use the end of another animation. So as with the line example, you can chain several animations together, and the underlying example I've used here does that. There was in SVG an attribute called access key, which was meant to let you specify a key that someone could press, and that would start an animation. As with the current approach of using JavaScript to trap keyboard events, this is problematic for lots of reasons. Plus, it doesn't work because it conflicts with the HTML access key attribute. And anyway, interacting with the web is hard, particularly for keyboard users. If you go to the next slide, this is all the JavaScript that's included in the source code of that graphic. The rest is SVG that looks like HTML and uses animation. And it's really just to use JavaScript so that if someone clicks on a button using the keys that they would expect, the spacebar and the enter key, it will pretend that someone made a mouse click and then send the mouse click through the system. This is the sort of nonsense you have to do when you use Aria to recreate widgets as well. In SVG, you'll find that that kind of thing happens all the time. So there's the code for you. Next slide, please. As I said, the animation doesn't change the underlying document. The document object model is the same. All of the things that were in the document are still in the document. What we have done is use an Aria live region. And so the status region, and if you poke in the source code, you'll find that, in fact, the document works in Spanish and English. And the status region is just an Aria live region. So each time the thing that's displayed gets changed, what's reported to the API, the accessibility API in the screen reader, also gets updated. If we move to the next slide, we've animated the visibility attribute, and that means that there are in various bits of text all laid in the same place, and one after the other they become visible, and then their visibility is removed. And changing the visibility is sufficient in most browsers to actually make the Aria live region work. It reports nicely what's going on. It's less than perfect because it simply piles the text in a queue to get read out. If you have a lot of changes, if you start the animation while the browser is still reading the descriptions of the graphic as a whole, and there are various bits which are described, it can get quite messy. So exploring the examples will give you a feel for what I've used to try and make it more or less comprehensible. And depending on your screen reader and browser combination, it's more or less comprehensible. Oddly enough, Macintosh users seem to be at a distinct advantage here. The voiceover interaction with Chromium-based, Blink-based browsers, whether it's Chrome, Yandex, Opera, even Vivaldi, works remarkably well, despite the normal reputation of those combinations. The next slide. The worst thing in using SVG animation is it doesn't work at all in Microsoft browsers. It's simply not supported. So you have to use JavaScript. And I've provided a link which I suggest you don't follow, but it basically gives you well-commented code, but if you strip out all the comments and cut it down to plain code, you get a page or so to do what SVG animation does in a line or so. Because using JavaScript, you have to do all of your own calculations. This is also annoying because you can't reason over your JavaScript in the same way. You have to write all of your own magic tools to interpret it. But SVG animation has been around, is shipped in pretty much everything except IE and Edge, including all of those 15-year-old implementations on what were then really fancy phones that don't have anything like the power of what would now be considered a cheap giveaway smartwatch. So it certainly can be done, and it has a bunch of uses. Next slide, please. The future of SVG, next slide, please, is in terms of enhancing accessibility, one of the things that people need is to see examples. Working on examples is really important. It will be good to fix some browser bugs, and especially to improve the tools that are used to create SVG. One of the big areas of uptake is data visualization. So while some tools use Canvas or some other kind of magic, CSS background sprites, and produce completely inaccessible data visualizations, there's a lot of uptake of SVG for data visualization. And if only the libraries that people used automatically did the kind of things we've seen here, the web could be a whole lot better. SVG certainly can be improved in terms of accessibility, but in very many ways it can be made accessible today. Next slide, please. So in terms of specifications, SVG2, where is this going to go? And this is essentially a question of, should SVG2 be cut down to just the things that work in browsers today, or should there continue to be development on it? Because there are various other features that people who do very rich graphics want to have in SVG, even if they don't work in browsers. And there's a political argument about which one of these is more important and who's going to do the work. One way or another, we will get an SVG2 specification, and at least one flavor of that I expect to explain what really works today. There's work on SVG accessibility API mappings. This is essentially figuring out how Aria behaves and documenting it for SVG. This work is done. The same for HTML and various other things. And there have been noises about creating a graphics module for Aria, being able to describe things that are more common for graphics and have Aria markup to do that. I've put a link there. You can go and comment on that idea. You can comment on the proposals. There are various different proposals floating around. It's very early stage, and I'm not entirely convinced that it's the right way to be going at all, but further feedback from real usage would be appreciated. Next slide, please. So thank you to, in particular, Leonie Watson, who did a lot of the work on making the line chart into a table. Leonie and Zelle Shell were amongst the people who did lots of the testing for me. People who produced lots of the other diagrams. The source code in here, you can actually take and use for anything you want. It's been cleared through and donated, and I'm grateful for that. Next slide. There are a couple of documents that are useful to look at if you're going beyond this. There's some stuff out there. If you do a search for SVG accessibility, you find a relatively small amount of documentation. You can probably read it all. Please do. But in particular, the Aria authoring practices, which won't come up as SVG, but are valuable to explain how Aria should be built so that your interface does what people expect. And there's a wiki that W3C has, which holds a whole lot of stuff, and that could use love and attention. If you get motivated, go right on that. Next. Thank you. As the thing says, there are no stupid questions. It's only stupid not to question. And the GitHub URL there is a repository of examples that you can play with. They're all linked in from the wiki as well. Are there questions?
Great. Thank you very much, Charles. Well, there was a question on Twitter from Estelle Wheel. Is it okay to put the Aria attributes on the SVG element, or is it better to put it on the rect element within the SVG? I think that was in reference to one of your examples earlier on the talk.
That would follow a couple of examples. You can put Aria attributes wherever they're relevant in the structure. The our Aria attributes are allowed all over SVG, and they are understood in much the same way as they would be. Sprinkle them around the same as you would in HTML. If the top level SVG element has a role or has some other Aria characteristic, some state, you can happily put it there. If you're enabling people to explore SVG, and I think one of the important things is if you have interesting SVG, not just rectangles, letting people explore inside the SVG means that you should have Aria inside it as well. You certainly want to have a description at the top level, though. Many people don't want to have to explore all the way around a graphic when a 3-line explanation is all they actually need.
And I also had a question about the process of creating accessible SVG. Can you recommend some good authoring tools or design processes to follow to create SVG? How do you go about doing that?
Yes, I am very fond myself of text editors because they do quite a good job. Rather than recommending directly, there's an article by Chris Koya that actually looks at a handful of tools which you can use. I don't have a link. I will update the slides to this before they're published to ensure there is a link. But if you look for creating accessible SVG, Chris Koya's article gives you a handful of useful tools. The problem that you will have with most tools is they create horribly complicated SVG. There is a Perl script called Scour, which will clean up SVG and make it much simpler to use. There are new visualization kind of libraries being produced fairly regularly, and they seem to get slowly better. The high charts tools, from which I took the line graph example, those are commercial tools for data visualization, but they take a slightly different approach in their sort of commercial version, and they produce lots of good stuff by default. But very often, still unfortunately, the process involves taking something that was produced by a tool and then either running something like Scour over it or literally editing by hand, which is what I do, because I'm reasonably good at visualizing, turning a long list of graphic coordinates, which is just a stream of numbers, into a mental image of what that's going to produce.
Right. Great. Well, thank you very much again. I learned a heck of a lot on the accessibility potential of SVG. I hope everyone else who was listening got as much out of that presentation as I did. Thank you, Charles, and we'll be back again in 7 minutes for Andrew Arch in the next presentation in ID24. Thank you.
Thank you. Go out and use what you learned.